So let's
Oh,
let's read this first question. This is question number one, right? So for question number one, I'm trying to test a catapult for accuracy. It says, and I'm launching 5 kilogram balls. Now, the very first thing I want to ask you is that important? Is the 5 kilogram ball part important? You can either type it in the chat, you could just shout it out.
wait, no.
Yeah, I heard someone say no. That's not important, right? It's just a little detail that they're telling us. We don't have any equations right now that have mass in them, all right? So I'm launching these balls and I'm launching them horizontally with an initial velocity of 36 meters per second. And I'm launching them off a cliff. So the setup is like this. I have my cliff, I have my catapult, and my catapult is launching a ball like that. Now, if the initial velocity of the ball is 36, that initial velocity is going to be velocity in the x direction.
Wait, so when it says initial velocity, then we think that it's Vx.
Well, so there's a few other
But when it
clues.
says horizontally,
I'm sorry, say that again. Right,
so if it was okay, okay,
right.
got it.
Because it says that they're being launched horizontally. Horizontally is in the x direction, so that means it's vx. If we were launching balls, and this we're going to get into this next week. If we were launching balls at an angle, so like it was a ground to ground problem, let's say that we were throwing a ball to our friend, um, then the initial velocity would not be vx, right? Some component of the velocity would be in the x direction, the other component would be in the y, right? So, but because it says we're launching them horizontally, that's what tells us it's vx. Um, Now the cliff is 425 meters high, so that is going to be distance in the y direction. Because the height, you guys, is is how far that ball is going to fall from, right? So that's dy. Now it's asking us to calculate two things. It wants us to calculate the range. By definition, you guys, the range is dx. It's how far away horizontally it's moved from the launch point. So range is always going to be dx. Always, 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 always. No matter what. So you can write that down. And then it wants the final velocity. So that's going to be vf. So even if you're totally stuck on the problem, at least write this stuff down. You get 4 out of 10 points, right? Now there's a few other things that we actually know. We always know the acceleration in these problems. We always know little g is going to be 9.8. Now remember, acceleration is only 9.8 when something is in free fall. At some point, you guys are going to start just randomly putting 9.8 everywhere. Don't do that. It's only the acceleration for free fall, okay? So, yesterday when we did our problem, I told you the very first step, the first thing that you should always do, if you're not given time and air, find out the time and air. Find out how long it takes to fall. Now, how long it takes to fall is independent of Vx. The only thing that affects the time it takes to fall or the time that it's in the air is dy. So I can use this equation. Dy equals original velocity in the y times time plus 1/2 gravity times squared. So this, you guys, this should be the first, like I said, this should always be the first step. If you're not given the time and air, just find it. And it always depends on the height. So I'll plug in 425 here. And that's going to equal... Now, what's the starting speed in the y direction? We actually know that as well. Because it was launched horizontally, there's one moment in time, we called it our Wile E. Coyote moment, where he runs out from the cliff and he's not falling yet, right? So for that one brief moment in time, the starting speed in the y direction will be 0. So that'll be 0. Plus 1/2 times 9.8. Oops. 9.8. There we go. Times the time squared. So if I just do the arithmetic part of this, it'll be 425 equals, this is 0 times anything will be 0. 0 plus the anything will just be that anything. So it'll be 425 equals 4.9 t squared. And then I got to get rid of that 4.9. You guys know you divide both sides by that. Can someone either shout out or type in the box what 425 divided by 4.9 is?
86.7.
86.7. And then I don't want t squared. T squared equals 86.7, so I got to take square root of that. So the time in error is going to be 9 point what? 9.3. Okay.
I also have a question.
All right.
For the velocity, like original,
Mm-hmm.
is it always, should we assume if it doesn't say it and it's being like kicked off horizontally, that it's gonna be a 0?
Right. So if it's launched horizontally, the starting speed in the y direction will always be 0, because
Okay.
that's equivalent actually to holding it and then dropping it. So if I launch it horizontally, the moment that it leaves the launcher, for one brief moment in time, it hasn't fallen yet, right? And so the starting speed at that one brief moment in time is 0 in the up and down direction.
Okay, and then if it would say like vertically, then what? Like,
So if you launch a ball vertically, then the starting speed would not be 0 in the y direction, right? And so, and that's what we're going to talk about next week. If I were to throw you a ball, normally I don't throw it to you horizontally. I throw it up in the air, right? So I throw it in an angle.
yeah.
If I throw a ball in an angle, the starting speed in the y direction is not 0. I gave it some speed,
Okay.
right? And I'm going to show you guys how to handle that. And if we get to the point where you're good at these problems, the ground to ground problems will be okay, right? Once you understand this, then I'll get you to the point where you can understand everything. So now this actually wasn't, we didn't solve for anything in this problem yet, but we can use the time to solve for the range. All right? And this is how we're going to do that. I'm going to move this out of the way. I'm going to move it slightly to the left. And let's do the range first. So I want to find dx. So dx is my question mark. I know Vx. That was my starting speed. Vx equals 36. And then the time, that's equal to 9.3 seconds. So in the x direction, remember, we have one single equation, one that we can use. And that is that Vx equals dx over t. And the reason we only have that one is because in the x direction, remember, velocity is always constant. It never changes. So I can take the 36. I set that equal to dx, which is the range, divided by the time. Oh, we know the time. Sorry, that's 9.3. So divided by 9.3 seconds. And then right now this is being divided. So I think you guys know you have to multiply both sides by 9.3. So if I take 36 times 9.3, what would I get?
334.8.
334.8 meters. Oops. Okay. So if I want to solve for range, I need to know two things, right? I need to know the horizontal velocity and I need to know the time. Well, I already had the horizontal velocity, so I had to figure out the time, right? So just to figure out range, that was a two-step problem. All right? Now, to figure out final velocity, that's more than a two-step problem. So let me, I'm going to clone that page. Okay. And we're going to get rid of some of this work if that's okay with you. So we know the time. We know how we got it. So I'm going to erase that. Okay, the time in error is 9.3. We'll write that up here. And then we know the range. We actually don't need that anymore, so I'm going to delete it. Okay. Now, oops. So now it's asking for the final velocity of the ball. All right. The final velocity, you guys, in order to find that, I'm going to need a few things. I'm going to need, I'm going to need the velocity in the x direction. So that'll be Vx. I'm going to need the velocity in the y direction. That will be V, the final velocity in the y direction, that will be Vfy. Okay? And then if I find the vector sum of those two, that ends up being the final velocity. So that would be the velocity if I had a radar gun. The speed would be represented by this vector. And then if I was able to get the angle in relation to the ground, it would be this angle.
Question.
Yep.
So VF and VFY are two different things.
They
We're not
are.
Solving
right. So
we're not solving for just one of those.
No, right. We have to solve for both. Because I can't get VF, which is the actual final velocity, without finding out VFY.
Okay.
And I know, because I know that Vx is 36. That never changed. In the x direction, as this ball was flying along, it was always covering 36 meters every second. But in the y direction, the speed was getting bigger and bigger and bigger and bigger because it was falling, right? Falling towards the earth, and it was accelerating at 9.8. So at any one moment that this thing was falling, right? It was getting faster and faster and faster and faster. So remember, VF, that is the actual final velocity. If I had a radar gun, that's what it would give me. But I can't, there's no way I could directly calculate it, so I'm going to have to use vectors to calculate it. So I know Vx already. I've got to find Vfy. Luckily we have an equation for that. So final velocity in the y direction, that's equal to original velocity in the y direction plus gravity times time. Okay? Now, remember, we weren't given time, but we already calculated it. So that's why I said the very first thing you should always do in these problems, find the time and error. So VFY, that's going to equal 0. That's the Wile E. Coyote moment. Just runs out, hasn't started falling yet. Plus gravity, which is 9.8, times our time, which is 9.3. So the final velocity in the y direction is going to be pretty high. 9.8 times 9.3. What is that?
91.14.
91.14. I'm just going to write it down as
Yeah, this
9.
one.
I'm sorry?
Just do that.
Yeah, I'm just going to write it down as 91.1. Thanks. I appreciate it. So we'll just do the tenths, if that's all right with everybody. Just so you guys know, if on your test, if you did it to the hundredths, I'm totally fine with that as well. So 91.1 meters per second. Okay. So I know the speed in the x direction, I know the speed in the y direction, so I could figure out what the actual speed is by finding this hypotenuse. So that would be 36 squared plus 91.1 squared equals c squared. And if you punch that in your calculator and take the square root, can someone do that for me? I'm trying to do it too. Trying to pull up my calculator.
97.9.
Oh, thank you. So 97.9. So that means that the actual speed is 97.9 meters per second. So my radar gun, that's what it'll read. Now, that's not the velocity though, right? Because I need the angle and the speed for the velocity. So to find that angle, we've been using inverse tan. Might as well just stick with it. So the inverse tangent of that angle is the opposite side, 91.1. Over the adjacent side, 36. And if I punch that in my calculator, can someone shout it out?
68.4.
I'm sorry, what was it?
68.4.
68.4.
Okay, wait. I'm sorry. I have questions.
No, that's fine.
So I'm assuming whatever you have so if we had v at final velocity and we didn't have final velocity y, then we would use a different we wouldn't use tan, right?
Well, that's exactly right. Right.
So what we have provided is what we should do, and then for the angles, could we just pick whatever?
Yeah, yes, that you can. The reason that I always pick this angle for projectiles is because I don't know if you guys remember from geometry class, if I have two parallel lines and I bisect them with a line, that the angles that are opposite on that line are the same. And so this angle is the same as this angle, and so it's hitting at 68.4 degrees with respect to the ground, if that makes sense.
Okay, yeah.
Right, so I always pick the one that it hits with respect to the ground. Now, if you find this one, you could still, if you added 90 more degrees to it, then that would also be the angle that it hits with respect to the ground, right? But I would just pick this one. Just do this one.
Are these always right triangles?
Yeah, it'll always be a right triangle because we're looking at the x and the y, right? And the x and y coordinates are always at a right angle to each other.
Because they always used to tell us in geometry, don't assume it's a right angle. You always have to be told first, even if it looks like one. So that's what I was just asking.
No, right. No, that's a good point. But by definition, if I write this as x and this is y, by definition, they have to be right angles. So I guess that would be me telling you they're right angles.
All right, thank you.
Yeah, you're welcome. So there's a lot of steps here, you guys, and I'm glad you're asking questions because I was a little worried that you wouldn't. because I know people have questions. This is not, like I said, this is not easy. It's not even easy when you're with me. So to solve this problem, we had to solve time. Then we had to solve for final velocity in the y. Then we had to set up our triangle and do the hypotenuse and the angle. So this was really a 4-step problem, right?
Wait, what is the final velocity?
So the final velocity would be 97.9 meters per second at 68.4 degrees.
Oh, okay.
So that's it right there. We figured it out. So this, I'm going to write this down. That is VF.
I have another question.
Okay, that's fine.
So since we've been doing range is dx, right?
That's right.
So what would air be?
So, okay. So the height is always in the y, so that's dy. So dy is height, and then range, we'll go back to this one. The range is dx. So if I were to, remember?
So the air would be dy.
Right. So the time in air is only determined by dy.
Okay.
Okay. Now I will say, so here's the thing about physics, you guys. I can always put wrinkles in things. Physics is more about problem solving than it is about memorizing equations and stuff. All right. Physics is very, very different than a lot of the sciences you've done up to this point, and it's very different than math as you've been taught up to this point, probably. Because in math, you're always taught like to follow a certain procedure and go through step by step, right? And in these physics problems, you're not always going to be able to do that, right? You're going to have to look at it and analyze it and use your brain and problem solve through it. It's not like, I can't tell you, you will do this every single time, because then a wrinkle will be thrown into the problem and it's going to be slightly different. All right? So the one thing I will say about this class, it will make you smarter, right? It'll make you better. It'll make you more confident in your problem solving, no matter what you do, whether you're going to be a social studies teacher or a writer or whatever. Okay? So that, I told you my main goal was to make you guys better problem solvers, and this is kind of proof of that. Okay? So should we do the second problem then? Do you want to go on to problem number 2? Yeah? Okay. So or unless if you'd rather start with 3 or 4, someone can shout that out now. Otherwise, I'll go to problem number 2. Okay, I'm going to assume that's problem number 2. So in problem number 2, I do have Wile E. Coyote. All right. So Wile E. Coyote is chasing the Roadrunner. He's going too fast, and before he realizes it, he's flying through the air. And he's going to crash on the ground. Just so you guys know, Wile E. Coyote never dies, but he's always like, he doesn't ever feel good when he hits the ground. Okay? So, we're not going to kill any coyotes in physics. So what it's saying is that the cliff is 125 meters high. So I'm going to kind of draw this out just so I have an idea of what happened here. So Wile E. Coyote, he is on this cliff. This is a really high cliff. It's 125 meters. Okay. Now the height, you guys know, this 125 meters, that's always dy. I'll write it down separately here, but the height is always dy. That's what we can use to find the time in air. Because as long as it's launched horizontally, the only thing that determines how long it's in the air is the height that it's dropped from, or the height that it falls from. Now, he's going fast enough that he lands 68 meters from the base of the cliff. All right. Now that is the range, and that's also dx. That's the horizontal distance he lands from the base of the cliff. So dx is 68 meters, dy is 125. Now this problem, only has us solving for one thing. It's how fast was he running when he ran out of real estate. So how fast was he running when he got to this point right before he fell off the cliff?
Wait, Mr. V,
Yeah,
is it asking for the VX or the
that
VX?
it is that it's asking for VX. So VX is going to be the speed that he was running at the very beginning. He was running horizontally right off this cliff, so that is VX. Okay? And this problem is easier than the last one. It's got some of the same elements though. Well, it's easier because we're having to solve for less, right? So the first thing that we want to do is we want to find time and error. And we're going to use that dy equation for that. So dy equals the original velocity in the y direction times time plus 1/2 gt squared. So we know dy, it's 125. Now this original velocity in the y direction, it's literally Wile E. Coyote. So he has that moment when he runs out for one brief moment in time. His starting speed in the y direction, that will be 0. And once again, that's because he's running out horizontally. You know, he's running on the ground and then he's dropped. And that'll be 1/2 times 9.8 times t squared. So if I do the arithmetic part of this, it'll be 125 equals 4.9 times t squared. Now I want to get rid of this 4.9, so you guys know I divide both sides by that. So then t squared will equal, does anybody know what that is?
27.8.
27.8. And then I have to take the square root of that. So the square root of that is
5.3.
5.3. Okay, so he's in the air for 5.3 seconds. Now in the x direction, remember, I have one single equation. And that's Vx equals dx divided by time. And I don't know Vx. That's what I'm looking for. I know dx. That was the range. It was how far he landed from the base of the cliff. 68 meters. Oops. And the time, we know is 5.3 seconds. So I don't even have to do algebra to solve for this one. I get that his starting speed, the horizontal speed, is equal to
13.6.
13.
So I'm guessing since it's asking just one question, we don't have to do like the resulting.
You do not.
Okay.
Yep, for this problem, that's all we have to do. So I want to do at least one more. Does anybody have a preference whether we do 3 or 4?
Do 4.
Do 4, all right. Okay, so this is number 4. I have a hunter in a tree, and I'm launching a shot horizontally with the slingshot. And then the hunter hits her prey in the foot. Okay, so here's the hunter. I know it says she's in a tree. You know, she's standing like in this tree on a little platform, I guess. Okay, and she's launching a rock horizontally. The rock is going to fall. Right? Take this path. She says her target is hit 1.77 seconds after the shot. So this time, I'm actually given the time in error. I don't have to solve for it. So the time in error is 1.77. I want to know a few. I also know she releases a shot at 22 meters per second. So because she fired that shot horizontally, that was Vx. That's not going to change. So we know Vx is 22. We might as well write down right now, just so that we remember it, because we're firing this horizontally. For one very brief moment in time, at the very, very beginning, the speed in the up and down direction in the y direction is going to be 0. Okay? And so these are the things I want to find out. It says, how tall is the tree? Well, that is dy. That's the height of the tree, right? So I want to find out how tall the tree is. I want to know how far from the bottom of the tree was her target. Well, that's dx, right? Because the how tall, that was this direction. Oops. Once again, the how tall was this direction, and the how far from the bottom of the tree, that's this direction. That's dx. So we need to find dy, then we need to find dx. And then we have to find out the final velocity, all right? What velocity was the shot traveling when it struck the target? That is going to be the final velocity. And that's, we're going to have to solve for Vx and Vfy and find the hypotenuse for that one. So for dy, that's the easiest one to solve for. Well, I don't know. They're both. For dx, we have to do a little bit of algebra, not much. But dy, we don't even have to do algebra. So if I look at the equation for dy, there's two of them, but I'm going to use dy equals voy times time plus 1/2 gravity times time squared. So starting speed in the y direction is 0. Time is 1.77. Gravity is 9.8. Time, once again, 1.77. And we're going to square that whole thing. So can someone tell me what that equals?
I got a big number. I got 1535112.1. I don't know. I feel like that's wrong.
No, yeah, it should be something along the lines of 13 is my guess.
Oh yeah, that is definitely something wrong.
15?
I got 15.4.
15.4. Yeah, so my guess is that you just left off a decimal or something. Maybe here. Maybe this 1.77. Maybe you accidentally put 177.
Oh yeah, I did do that.
Okay. Well, and once again, so you knew enough to know that like something was funky, but you knew what you were doing. So this is 15.4 meters. Okay. Now, what equation will we use to find dx?
Vx equals dx over time.
Yep, that's right. So Vx equals dx over time. And so we will have to do a tiny little bit of algebra here. So Vx is 22. Dx is what we're looking for. And the time we said was 1.77. So to find dx, we just times both sides by 1.77 to get rid of it. And what do I end up with?
38.9.
38.9 meters. So that she was 15.4 meters high in the tree, and the person or whatever it was that she was shooting at was 38.9 meters away from her. So we good so far, everyone? Okay. So now I'm going to copy this problem, copy this page, and let's look at, so we need to find VF. I'm going to delete this part here. And let's draw out our triangles again. So we know that we're going to have some velocity in the x direction, okay? And that we'll have some velocity in the y direction. And then if we take and find the resultant of that triangle, that'll be the actual velocity. So we already know that Vx is 22. It's supposed to be an x. So we know that Vx equals 22. We don't know what VFY is yet. But we have that equation for VFY. VFY equals original velocity in the y times time plus 1/2 GT squared. I'm running out of room here. There we go. All right. So then we know that VFY is going to equal 0 times 1.77 plus 1/2. Oh wait, you guys, hold on, nobody stop me. I wrote down the wrong equation. VFY is VOYT plus GT. Or it's VFY plus GT. I'm like having a brain cramp. Hold on. So VFY equals VOY plus gravity times time. Right? That's the equation that's on your sheet, isn't it? So that's 0 plus 9.8 times 1.77. And 9.8 times 1.77, that's going to equal like 17.4, 17.3. So VFY right here, this part of the triangle, 17.3. Okay, so the top is 22, the bottom 17.3 to find the hypotenuse, to find VF. Okay, I'm going to find this angle, and I'm going to find the hypotenuse. So the speed part of it, which is the hypotenuse, that's going to be 22 squared plus 17.3 squared equals c squared. So I punch that in my calculator, take the square root. Does anybody have the answer?
I got 20. Well, it's 27.9, but I just rendered it to 28.
Yep. Okay, I'm all right with that. So the actual speed will be 28 meters per second. If I had the radar gun, that's what it would read. And then the angle, we've always keep just using tangent, so we'll just do it. But you guys could use whatever you want, whatever you're comfortable with. So the inverse tan of the opposite side, which is 17.3, divided by the adjacent side, which is 22. That's going to give us an angle of
38.1.
38.1. And the reason that this angle is so much smaller than the angle in our other problems is because she wasn't very high in this tree. So she didn't gain as much speed because of gravity. Oh, why did I write meters per second? That's supposed to be degrees. So 28 meters per second at 38.1 degrees. That equals VF.
Mr. V,
Yeah.
for the Pythagorean theorem to find the VF, I got 17.4. I don't know what I did wrong.
Okay, hold on. Can anybody confirm? Did anybody get... $22 squared 484. 17.
Oh wait, never mind. It's because I put 2.2.
Oh, okay, okay.
Never mind.
That makes more sense. Oh yeah, it has to be. Well, it has to be bigger than 22. Can't be, right? Because it has to be the longest side, right? So does anybody have questions at this point?